Alright, so we'll be talking about allotropes of carbon. Alright, allotropes of carbon. So before we even do this, I need to explain this term to you. Allotrope. What does allotrope mean? Okay. Now, you see, for example, there are many elements which they are made up of the same element. Like for example, in this case, you have, let's say, carbon, right? You have carbon. But carbon can arrange itself in many different ways, okay? In many different ways. For example, one of the arrangement is what we know as diamond, okay? Diamond. In diamond, or in the diamond arrangement, carbon is, each atom of carbon is bonded to another 4 carbon atoms, okay? Another 4 carbon atoms. Then each of these carbon atoms are then further bonded to another 4 carbon atoms. So every carbon atom is covalently bonded to other carbon atoms, okay? Covalently bonded to other carbon atoms. And this just goes on and on and on. It's almost like infinity in 3 dimensions. That is one structure of carbon which we call diamond. But carbon can also arrange itself in this way. That means one carbon attached to another carbon, attached to another carbon, attached to another carbon, attached to another carbon, attached to another, attached to another. So at the moment you see that it looks like a hexagon ring, okay? It looks like a hexagon ring. So then this can, then is another hexagon ring, another one, so it just goes on, another one. So in this hexagon ring, what you can see is, or what I hope you see is, each carbon is bonded 1, 2, 3. Only 3 bondings per carbon. But we do know carbon actually has 4 valence electrons. So in the case of diamond just now, each carbon has 1, 2, 3, 4 bonding. But in this case, which we call graphite, okay, graphite, we call this graphite, carbon is only attached to 3 other carbons, which means that there is 1 electron which is free. So every carbon has 1 electron which is free, and this electron can be delocalized. That means it can move from one place to another place, it can continuously move. And that is why graphite can conduct electricity. Okay, graphite can conduct electricity. So in the case of graphite, right, if it's, this is what I drew just now for you. What happens in the case of graphite is it is arranged by layers. So this is one layer, and then this is another layer, and then this is another layer, and then there are another layer. So many layers and layers and layers of this graphite sheet. This is a sheet. Each one of this sheet, each one of this is called graphene. Okay, it's called graphene. So together they're called graphite. Okay, what is holding them together? Like for example, let me erase this. Now, between these sheets, right? Between these sheets, the attraction that exists between these sheets, this attraction is called dispersion forces. Dispersion force. Okay, dispersion force. So what happens here is, when, let's say in a pencil lead, you have graphite. So when you write on the surface of paper, each of these layers get removed onto the piece of paper, and that appears to you as writing. Okay, so this is the layers. So between the layers, there is dispersion forces. Meanwhile, in the case of diamond just now, there is no such thing. Every carbon atom is attached to another carbon atom. And then in the case of graphite just now, it can conduct electricity in this way, within the layers. It cannot conduct electricity in this way. Okay, cannot conduct electricity in this way. It can only conduct within the layers, not between the layers. Okay, so this is what we call allotropes. You see, they are both made up of carbon. They are both made up of carbon, but the difference is diamond is one of the hardest known substances to men and women. Let's not be sexist, no? But graphite, on the other hand, is total opposite. Graphite is soft. Graphite is used as lubricant. So they are totally different characters, although they are made from the exact same thing, which is carbon. But one is very hard and the other one is very soft. That's the difference, okay? So, coming back to this again, you see, carbon also exists as another type of allotrope, which is amorphous. And this is like in the case of coal and charcoal. If you have ever done barbecue before, okay, barbecue, when the wood is burned and then after that you see charcoal, if you knock it, it'll just shatter into powder. Okay, it'll just shatter into powder. That is amorphous. That means it's very brittle. It can just like break into powder. Same thing goes with coal as well. Coal, if you take a big hammer and you whack it, it will shatter into small pieces. Same thing. All right, they are amorphous. They have a lot of empty space between them. So carbon can exist as diamond. It can exist as graphite. It can exist as coal and charcoal. Okay, so that's basically it. So in the case of graphite, you see, this is what I told you just now. All right, the weak bonds between the layers allows them to slide over one another. So graphite is relatively soft and slippery, makes it useful as a lubricant. Delocalized electrons within the graphite allows it to act as an electrical conductor. Then there are other types of allotropes which are called fullerenes. This looks like a ball, and this is made up of 60 carbons in a ball structure. This is sometimes called a buckyky buckyball. Is named after the scientist who discovered this. So this is made up, it's like a football, and it's made up of 60 carbons. Okay, and then you also have this. These are called nanotubes. All right, cylindrical fullerenes are called nanotubes, are known as nanotubes. They are long tubes. And then one of the materials which now is becoming very, very popular is graphene. Graphene is a better conductor of electricity than silver, better than conductor of heat than diamond, and stronger than steel. Graphene, see this word here, graphene, that makes up one sheet of graphite. That means, remember just now, if we come back here again, if we remove just this one layer, right? If we remove this one layer, that's called graphene, okay? But it's very, very strong. So that's what it's saying here, all right? There are many possible uses of graphene, but research is needed to more easily and cheaply to produce sheets of graphene. So this can be used for many purposes like delivery of drugs or chemicals and protection, let's say for motorbike riding jackets, or in the army you need now you use Kevlar, right? So instead of Kevlar you can probably use this. It's lighter. So there are many possible uses for this. So that's the end of this part. Next we'll be going into liquids.